Okay, so by request, I'm going to take just a few minutes to go through the whole curve fitting, just to discuss some of that. It'll probably be a little longer than what I would necessarily do because I'm going to go ahead and add tangents and cotangents at the end. So I'll just look at sines and cosines first, secants and cosecants second, and tangents and cotangents, which I'm not going to hold you responsible for the test. So if that's what you're worried about, you don't need to. But if you kind of want to know and how that works, then you can watch all the way to the end if you want to find out that piece of information. One thing that's really important to know is that when you look at these waves, there are lots and lots of waves to be seen here. And we should be aware that when you graph a sine wave generally has this shape to it. You know, it starts at the middle and it goes up and it comes back down like this. That's what a sine wave looks like. And if we were to look at this wave from here, around here to here, that looks like a positive sine wave. A negative sine wave actually has the same kind of general shape as just flipped over. So if I were to look at this graph from here to here, this looks like a negative sine wave. A cosine starts at the top and ends back at the top. I can see a cosine wave here. And of course, a negative cosine starts at the bottom and ends back at the bottom, and I can see that right here. So based on the fact that there's a lot of ways to represent this, we're going to just try to pick a couple of them. We don't have to cover every possible one. We're just going to cover some. So what I personally like to do is I like to come in here and simply draw a box. And my go-to is I look for cosines in all cases if I can. So I'm going to start right here. And you're going to notice, and I just picked it because it was kind of close to the origin is the only reason I picked that. Some of you guys might have said, well, why didn't you pick over here? I totally could have. There's no reason not to. I just found it easier. Now, in terms of how this looks, it looks like I have picked a negative cosine wave. Now I need to figure out some extra pieces. So remember when we do this, we need to figure out what A is, our amplitude. We need to figure out what B is, which is going to help us with our period. We need to figure out what our phase shift, the left and right, and then what the up and down. Those are the three things, the four things, excuse me, we need to find. But what's kind of cool is when you go through all of this, I'm going to put a little 1 here and a 2 here. The value for the amplitude, if you thought of it as a sine or a cosine, is going to be the same. So it doesn't matter if you think of this as a sine or a cosine, they're going to have the same A value. And so I noticed that my box that I generated looks like this. So it looks like the midline got kicked up 1 unit. Notice it doesn't matter which representation. I picked the sine and the cosine were just up 1 unit. I also noticed from the midline up, it goes up 3 and down 3. That's again our amplitude. Again, doesn't matter if it's positive or negative. The amplitude is an absolute value, so it's just the number 3. Now the cosine should have started at the left edge of the box, so the cosine started right here. Well, this does make it a little bit challenging because the way the graph paper looks. So, you know, I have to study the graph paper, and that's how I figured out the 2 and the 4. But when I look this way, it's a little strange. I would notice there's 1, 2, 3, 4, 5, 6, 7, 8 lines before I got to pi. So that means each one of these vertical lines represents pi over 8. And if there's 1, 2 back, that would be negative 2 pi over 8 or pi over 4. Now, I don't want to count all the way over here, so I jump to here. This would be 8, 9, 10, 11, 12, 13, 14 pi over 8, or 7 pi over 4. And let me go ahead and pause my video for a moment. I'll be right back. All right, well, it seems that I had somebody trying to join my Zoom because I was asking students if they needed help, and that student came and then went. So off we go back to this. So what I notice is from here to here is 8 pi over 4. So the period of this thing is 8 pi over 4, also known as 2 pi. Now, you have to know that the formula that I gave you is that the period is 2 pi over b. But in this case, if the period is 2 pi, that means b better be 1. So we could put a 1 there, But remember, in math, we don't really have to write the word 1. So I know that my amplitude is 3. I know my B value is 1. That makes my period 2 pi. I know my up and down shift is 1. And this cosine got kicked to the left, pi over 4. Remember opposites, how that works. And then the only thing I have left to do is figure out if I wanted to represent this as a sine. I change colors a little bit to make it a little bit more clear. A sine wave, remember, should start at the middle and go up, or start at the middle and go down. So I just thought this was a pretty nice way to look at this one, because it started in the middle and went up. And so this value where that started, so I could have made a box started here going this way, would have happened to the right, pi over 4. And that's the end of that sine wave. Now, coming to this one, there's something also about this one that is a little bit tricky, because when I looked at it, and I did design this to be a little bit of a challenging question, is that when you look for these little lattice points, is what we call those places where it's really easy to see. When we look at this problem, I see a very nice point right here. It hits really pretty, and I can tell that that point right there happens at -3 pi over 4. But when I go one wave over to here, it hits at an ugly place, which I don't even know the name of that place, because it doesn't even look in the middle. And so I'm looking for a start and an end that's pretty. And on this particular case, this is actually kind of pretty, which is strange. I don't do this frequently, but I'll do this occasionally in curve sketching. So I made kind of an exercise box, and I'll describe why that's the case in a second here. But the bottom is -3 and +5, which makes the middle 1. So let's go to the easy stuff first. So if I know these 3 values, then I know that this thing has been shifted up 1, regardless of it being represented as a sine or a cosine. It has an amplitude of 4, again, regardless of being a sine or a cosine. Here comes the fun part. Now, what I see, because I made a super box or a big box, this is not one cosine wave. It's 1, 2, 3 cosine waves. Ooh, up to the top, up to the top, up to the top. So if it went from here to here in exactly 2 pi, because it turns out it is, I rigged it to be kind of nice, but it fit 3 waves in that 2 pi, then each wave is 2 pi over 3 as a period, which means if 2 pi over b, as previously mentioned, is our period, then b is sitting right here. So that's going to make that wave go a little bit faster. And it looks to me like the cosine wave kicked over here to the right, 3 pi over 4. You could have picked a different place. That's just the one that I picked. A lot of people do different. And then I'm just going to come to here like this, and I'm going to look for a place where I see a nice lattice value, a place where it crosses that nice and pretty. That's not pretty, but that one is. And so this is the one I like. I'm going to pick this guy right here. This is what a single part of the cosine wave would look like. Notice, just like before, it started pretty and it ended ugly. But I could do 1, 2, 3. What do you know? It's pretty over here again. And that one actually kicked not left 3 pi over 4. It actually just kicked left pi over 4. So that's kind of the way that I personally do those. And this one was a positive sine wave, as we discussed, because it started in the middle and goes up. Now, if we look at a couple of secants and cosecants, when I look at those, everybody has their own way, but I'm going to start right here at this one and draw my box over here. And it looks like if I were going to try to draw the little wave in there, because remember how these U's, touched the curve. So since this is a curve going this way, then there has to be a wave coming inside here. So let me see, 1, 2, 3. It's about right there is the middle. So I think the curve is coming like this. And notice that when I graph this, that looks like a nice positive cosine wave drawn inside of that, which means we're actually looking at a secant. But if we move it a little bit, it could be a cosecant. But this one is a positive secant as I did it. Notice my phase shift on the left edge of the box was 0, so I don't need to deal with that. If this is 0 and over here is pi, it's a little hard to tell, but it is. So remember, if the period is 2 pi over b, to make a period of pi, then I would need to divide by 2. So this is going to be a 2 here. And then we're kind of getting there. Let's see, they're counting by 1. So here is 0, here is -4, so this is -2. So this graph, both of the graphs got kicked down 2 units. They have a vertical stretch factor of 2, see, because it went up 2, down 2. That's why these 2s. This 2 is this guy. A lot of 2s, sorry about that. But then if we looked for where this graph looks like a nice sine wave, I actually see this one right here, which is actually a negative sine wave kicked to the right, pi over 4. That's kind of what I see. Now, this one, I wanted to do a couple of them that were a little bit ornery. Sorry, got to be me. So again, I'm going to come into here and I'm going to draw from the bottom to the bottom. That would be a full cycle. Let's draw in our wave. It would go from here to here, which would go like this. I'm going to go ahead and not draw it dotted simply. It should be dotted, but I want to make sure it's very clear what I'm drawing in there. So this is a positive cosine wave, which means it would be a positive secant. But I'm also going to represent it as a cosecant. The middle of this box, according to the numbers at play, is a 1. So they both got kicked up, down 1 unit. I should make that a -1, shouldn't I? Let's make that a -1. And the amplitude, which is really called a stretch factor for secant and cosecant, it just gets stretched a half. It doesn't go up very high or down very high. That's why these two waves are so close together. Now, as far as my phase shift, that cosine got kicked. If that's pi over 4 and that's 0, then right in the middle of here would be pi over 8. It got kicked to the left, pi over 8. And what I notice, and this is, again, like I said, a little bit hard to do, but if this is minus pi over 8, you could count that because this is pi over 4 and that's in the middle. This one is 3 pi over 8. So from here to here is 4 pi over 8, also known as 2 pi over 4. Well, remember, if your period, 2 pi over 4, is 2 pi over b, that's going to make b 4. So I know that's 4 because I could count the period from here, and making an adjustment, the period is always 2 pi over b. So the only thing I would have left to do to finish it, because this one is done, I found A, B, C, and D, is I would like to find out what C is for the cosecant wave. So again, in looking at my cosecant wave, I noticed this right in the middle would be a nice place to start right here. But that's kind of cool because that one didn't actually shift over. The phase shift right there is at 0. But it is a negative looking wave because it was going down, and that's why I assigned it a negative coefficient. And so that's a little bit about sines, cosines, secants, and cosecants. Now, I did say that I would look at tangents and cotangents, and so I'll go ahead and do that. If you really don't want to worry yourself, you don't have to, but it's really not that difficult. So if I'm going to do a tangent, the first thing I need to do is identify where my asymptotes are. And again, everybody is going to be able to pick their own asymptotes. Some people would pick this one and this one. Some people pick here and here. I don't really care. I just personally decided to pick these two. So this is the left edge of my box is at pi over 4. And over here, this is actually at 9 pi over 4 if you count. And so from here to here is actually 8 pi over 4, also known as 2 pi. So the period of this thing all the way from here to here is a total of 2 pi. Now, what's a little interesting is unlike the other graphs, the period should be pi over b. And we just figured out that that has to be 2 pi. Well, the only way you can take pi divided by b and get 2 pi is if b is a half. So No matter what I do, whether I represent this as a tangent or a cotangent, my b value is going to be 1/2. I wish I didn't put this quite so close. So I'm going to move this pi over 4 up here. Now, to carry on, remember cotangents just go down. So this would be a normal cotangent graph with a phase shift to the right of pi over 4. Now, interestingly enough, for a tangent wave, remember the tangent goes to the middle of the box. So this is where it starts to get kind of weird. Right in the middle of 1 and 9 pi over 4 is 5 pi over 4 right here. This is the middle of the box. So I went right in the middle of 1 and 9 and I got 5 pi over 4 right in here. So that's where the tangent would go. It got kicked to the right 5 pi over 4 and tangent should go up. So this is going to be negative. But there's something extra special that just happened. The midline right here where the tangent hit the middle of the box told me my vertical shift, that it got kicked down exactly 3 units. See, 1, 2, 3, that's where the middle is. Now, the stretch factor is probably the hardest thing, but if you recall, we go to the left edge and the right edge of the box, and then we go to the middle, and then we find the middle of those two. So if I were to find the middle of those two, which would be right here, and I go to that, this is the quote-unquote box that we referred to. And so what I can see is I found out that my box is a total of 1, 2, 3, 4 units, which means my stretch factor is 2, and I've now finished my cotangent. So I'll go ahead and do one more, and then I'll call this good. This one cuts over here at minus 3 pi over 4, and over here at positive 5 pi over 4. That's kind of nice. It just so happened to be the same. So from here to here is 2 pi. So the period is 2 pi. But if that's pi over b, again, we've got a half. So if I were to represent it as a tangent, it would be 1/2 for the b value, same as the cotangent. Tangents like to curve up, and it does, so that one's positive, but cotangents like to go down, so that one's negative. Now let's go a little bit further. I need to find the middle of these two things. So right in the middle of -3 and +5 is 1 pi over 4 right here. So there's where I have it. So this is pi over 4 right here. See? Boom. So I know that my tangent goes to the middle of the box, and if the middle is at pi over 4, it got kicked to the right pi over 4, whereas the cotangent comes from the left, and it got kicked to the left 3 pi over 4. And then the only thing we have left to figure out is A and D. And so if I look here, I can see the middle is down 2. And last but not least, if I go to the middle of these, I'd be looking right here. And if I go to that, I can see that the total height of this wave, again, the middle would be here. Go to the middle of those two, and I find out how tall it was. It looks like it goes up 1 and down 1. Oh, I think I may have missed. I guess, I don't know. The numbers are weird. These are counting 1, 2, 3, 4. They're counting by halves. What do you know? So this is down 1. So let's fix that. I did not read my own graph paper right. It's counting by ones. And so if it went up 1 and down 1, then according to these, since 1 represents a half in the graph, then our amplitude, or our actually technically vertical stretch factor, is going to be a half. And that's my little presentation on curve sketching. And hopefully that helps. See you guys later. Bye-bye.